And this told us that a greenhouse effect can cause a planet to be a habitable planet over an enormous range of distances. Just an enormous range. So an atmosphere can make a planet habitable and keep it habitable in a great variety of places in planetary systems. And then we discovered something else. The satellite Europa of Jupiter, which has an equivalent insulator to keep its ocean, if you will, suitable for life. In this case, the insulator is a layer of ice about 10 kilometers thick. This is two views of the same face of Europa. No craters because the surface is very young. It's made of water ice, 10 kilometers thick. Underneath that ice, there is an ocean of water. The outer surface of this object is about 170 degrees below zero. But that 10 kilometers of ice creates an insulating layer so effective that water can be in liquid state at a few degrees above freezing in the ocean of Europa, which actually contains much more water than the ocean of Earth. And this tells us then that here we could have life far out in a planetary system where the outer surface is extremely cold, and yet inside this, due to the insulating properties, the conditions are suitable for life. There's a third way this happens, and that is just the surface of a planet itself acting as an insulator. And the Earth is an example of that. Deep in the Earth, at depths of several kilometers, there is a great deal of microbial life, very ancient microbial life. And if the sun turned off, that life would exist here on Earth for billions of years, just kept alive by the heat flowing out from the interior of the Earth. So there's a third kind of insulators, solid surface, in addition to the liquid surface, or the ice surface, as with Europa, or a heavy atmosphere. And that's telling us then that there are many ways by which planets can be kept habitable in places which 40 years ago we thought were ridiculous. This is a picture of the ice on Europa, ice flows. We're looking at an area about 50 kilometers across, and you see the ice flows which have broken off, floated on whatever kind of slush or whatever is there sometime in the past. It's now frozen, but this is evidence that there is liquid water beneath the surface. Now, what this says is that in planets like Uranus and Neptune, they're like that. There can be places where temperatures are suitable for life. The outer surface may be at 150, 200 degrees below zero Fahrenheit. But as you go down in the atmosphere, because of the great greenhouse effect of the atmosphere, the temperatures go up and up. And in fact, we have observed directly with radio telescopes that there are layers in all of Jupiter, Saturn, Uranus, and Neptune where the temperatures are as in this room. And if the chemicals are right, you could even have perhaps life there. Now that's a speculation. There's no solid surface, there is only gas. But here's a concept of what are called floaters. Kind of cute. For some reason they have turquoise spots on them. That's the artist's idea. What you're looking at here is what could occur only not very far, about 10 to 100 kilometers below the surface of the cloud layer which covers all of these planets. And by the way, this idea is an old one. It was first suggested by Ed Salpeter and Carl Sagan at Cornell in the first paper on extraterrestrial life which was ever accepted for publication in the Astrophysical Journal, which was a real milestone because the editor at that time was a very conservative guy and talking about little green men and let alone floaters floating in the atmosphere of Jupiter was pretty far out, and it was. Now, stars like the sun, which again 40 years ago we thought were the only place where you might find life. The more massive stars burn up their resources. They blink out too quickly to allow the evolution of any sophisticated life. That was our belief. We ruled out actually the great majority of stars, the M stars, the red dwarf stars. M stars call that by the astronomers. These are small stars with a mass about half that of the sun, but whose light is only a few percent that of the sun. And that meant that any planet of those stars would have to be huddled in close to the star in order to be warm enough to support life. And I guess you can already guess what's coming. A little greenhouse effect can take care of that, and they can be far out from the star and be warm enough for life. But there was another problem, which people thought was lethal to the idea of life on these stars. This is a conception of a Saturn-like planet orbiting a red dwarf star, glowing sort of a reddish color because the stars are red. There was another problem, and that is that if the planets were to huddle close enough to the star to be warm enough to have liquid water, the tidal force of the star would be extremely strong, and it would act on the star to cause the planet to keep one face to the star, just as the tidal force of the Earth keeps one face of the moon towards the Earth. And so it was felt that these would be very strange places with planets in synchronous rotation, one face towards the star at all times, and that meant one hemisphere of the star was in the dark, never got sunlight, starlight, became very cold, and this cold would freeze out the atmosphere and prevent there from being an atmosphere, and therefore preventing the origin of life. Now, recently, it has been recognized through calculations that this isn't so. That, of course, the star will heat the sunward hemisphere of the star, and here's an artist's conception of it. But this will cause an air circulation, just as it does on the Earth, where hot air rises, flows, in this case, towards the terminator, the boundary between light and dark, towards the cold backside of the star, and would warm the star, and then there would be a reverse flow underneath the gases flowing from the hot side. And the end result, as it turns out from theory, is that in fact the cold side, the dark side, is kept warm enough that the atmosphere does not freeze out. And so in fact these things could in fact be habitable.